So in this video, we want to look at solving example number 4, finding the Laplace transform of t minus 2 times the unit step of t minus 2. And we see that if we look at the list of translation theorems, we have the second translation theorem, form 1, and we can actually apply it in a straightforward manner. Note here that f of t minus a and the unit step of t minus a, that's the general formula. We have our unit step of t minus 2 here. So that matches up with the unit step of t minus a. And we have a function that is shifted, a t-shifted function. So when we're dealing with the second translation theorem, we're dealing with t shifts. That might be a term that's used in the class where t is shifted. So we're interested in finding big F of s, right? And remember, big F of s is the Laplace transform of f of t. But we have f of t minus a. F of t minus a in our problem, f of t minus a is equal to t minus 2. So how do we find f of t? Just f of t regularly. Well, just get rid of the shift. So every shift we see in our f of t, which we say our f of t minus a, which we say is t minus 2, we're going to get rid of the shift. So here we write, we know that f of t minus 2 is equal to t minus 2, right? To find f of t, we have to eliminate the shift. So we're just going to say f of t is equal to t. And we can verify this. We can go backwards and kind of prove this, because we can say, well, if f of t is equal to t, then f of t minus 2 would be t minus 2, because for every t we see in f of t, we're going to plug in t minus 2. So, and we know that to be true. So it basically comes down to making sure we can identify a function here in the looking back at the original problem that has a shift. And then the unit step, of course, it has to have that same exact shift to apply the second translation theorem. If this was like t minus 3 unit step of t minus 2, we wouldn't be able to apply the translation theorem because the shifts have to be the same. That's why this is a here and this is a here. But since that's not the case, we already know that f of t is equal to t. And so big F of s is just 1 over s squared, right? The Laplace of t, which is just 1 factorial over s raised to the n 1 plus 1, which is just s squared. So that's 1 over s squared. And our result is just simply e raised to the negative 2s, right? Because we have our a is equal to 2. And we're just going to multiply that by the 1 over s squared, which is big F of s.